Oh, yeah?
I'm making one right now. All right, we're going to do problem 42. The reason you probably didn't know how to do 42 was the fact that we skipped chapter 5. And it has to do with inverse and direct variation. So we'll look at it real quickly. So when you have something that is inversely related, you will get something that looks like this. We can think of this as y equals 1 over x. So as y gets bigger, x will get smaller, and vice versa. So this would be an example of inverse variation. So you're going to see that fraction there. The example gives you this information. It says g of 4 is equal to 1.2, and then it says inverse.
Thank you.
No problem. Alright, so g of 4 is equal to 1.2, and then it says it's an inverse square variation. So it even gives you this hint that we'll set it up this way. G of x equals k over x squared. So you see the squared here, and the fact that it's a fraction, that's that inverse variation. And you can think of your g of x as your y. So if we think of this as x, and this as y, so here's our y. We will have 1.2 is equal to k over our input, which is 4 squared. We end up squaring it and then multiplying each side by 16 and 16. These will cancel, and we have k is equal to 19.2. With that, we can go ahead and write our equation in. We did all that to solve for k. So now our new equation is g of x equals 19.2, which is our constant, all over x squared. And then it just asks you to evaluate a couple numbers. Our first input's 6. So g of 6 will be your input, 19.2 over 6 squared. And then we'll do the same thing with negative 3, 19.2 over negative 3 squared, and the two solutions are 8 over 15 reduced, and the other is 32 over 15, if you were to reduce both of them. So that's inverse variation. I wouldn't worry too much about that since I skipped that in terms of the content. You'll use a little bit of it in calculus, but for pre-calc, you're good. 62 is the other question you asked, which is trig. I think it had to do with tangent. So we're going to have to use our knowledge of the unit circle, find the exact value of tangent of 2 pi over 3. Thinking of the unit circle, where is 2 pi over 3? Quadrant 2. And I want to write down the coordinates there. Negative 1/2, rad 3 over 2. Okay, now, if we go back to what tangent is equal to, sine over cosine. And sine over cosine is equal to y over x. So now we're going to look at our y coordinate, which is rad 3 over 2 over our x. So if we were to expand this, we'd have rad 3 over 2 divided by negative 1/2. The 2's cancel. End up getting negative rad 3. Same denominator. Boom, you're done. So again, on 62, it's your knowledge of the unit circle, and then how tangent's related to sine and cosine to solve for that.